Hello and good afternoon my dear kids. Welcome back once again to this short tutorial video for class 8 students, and this one will be continued for the identities of algebraic expressions since we have done up to identity number 3. So in this video we will be learning how to use the identity number 4. Okay, so I've already said please memorize the identities, the 4 identities, because these are very important identities. And identity number 4, what we have here is a plus b into a minus b equals to a square minus b square. What do we see here is we got multiplication of two binomials, that is a plus b and a minus b, isn't it? If it is in this form, that is multiplication of binomials in this form, that is the first terms, two terms are same, second terms are also same, the first term of both the binomials are same, the second terms of both the binomials are same, and just that we got the opposite sign. So what you can do is simply square the first term minus square of the second term. Okay, so since it was from the exercise number 13 series, so the first question I have here, we got here is solution 1, question number 1. We got y plus 2, y minus 2, y plus 2 into y minus 2. So what we have here, y plus 2 into y minus 2, multiplication of binomials. So the first term y and y. See, second term also we got 2 and 2. We got multiplication of binomials with plus and minus, isn't it? So the expansion a square minus b square, simple. See, y square minus 2 square. So y square, as we know, y square into y square, isn't it? Minus 2 square over 4. So we are done here. See, easy one, isn't it? Okay, the second question we have here is 5p square minus 7q. See, 5p square plus 7q. Again, multiplication of binomials. The first terms are same, the second term is also same. It's just that the signs are different, minus and plus. So see, what we can do here, either it be a plus b, a minus b, or a minus b into a plus b, same thing, isn't it? We know because multiplication associated, that is 3 into 2 will give you 6, as well as 2 into 3 will give you 6, isn't it? So 5p square whole square minus, that is a square minus b square, 7q whole square. So 5p square, 5 square is 25, 5 into 5, p square square, p to the power 4, isn't it? Minus 7 square, 49, q square. See, we are done here. Okay. The third question we have here is a square plus b square into a square minus b square. Again, see, the first terms are same, the second terms is also same, just opposite signs. So a square minus b square, in place of a square we have, in place of a we got a square in here, simple. In place of b we got b square in here. So a square whole square minus b square whole square, e to the power 4 minus b to the power 4. Again we are done here. Okay, and yeah, one more question I have done for the fractional form as well. 1 by 3 minus 5x, 1 by 3 plus 5x. For fractional forms also the same thing. If you have multiplication of binomials, two terms with the first term and the second term same, with just opposite signs, as I said, this identity is applicable there. So 1 by 3 square, that is a square, minus b 5x square. So 1 by 3 square is 1 by 9 minus 5x square, it's 25x square. Okay, I hope you get that, isn't it? Similarly, again, see, all the questions are for the same identity, that is, so the terms are same, a square b cube, see, x cube y to the power 4, x cube y to the power 4 is just a minus and plus. Again, a square minus b square, in the term of a, what we have, a square b cube, so therefore see, a square b cube whole square minus, in place of b what we have, x cube y to the power 4, x cube y to the power 4 whole square, a square minus b square. So now opening up the term, what do I got? A square whole square means a to the power 4, b to the power 3 square means b to the power 6, isn't it? Minus x to the power 3 square, x to the power 6, y to the power 4 square, y to the power 8. You can simply just directly multiply their powers as well, isn't it? It's in the, remember the exponential form, a to the power m to the power n. What happens? A to the power m to the power n. If you got two exponents, two powers, the powers will be multiplied, isn't it? So say 2 into 2 is 4, 3 into 2 is 6, 3 into 2 is 6, the power of x, y, the power of y, y to the power 4 into 2, 4 into 2 is 8. See, this is also how it can be done. Okay, now this one, question number 2, what we have here is Now I got multiplication trinomial and a trinomial. But what do I see is, in the trinomial, what do I see is x plus y plus z and x plus y minus z. So see, if I can assume that the first two terms as one of the terms, simple x plus y, see, that is why I have placed a bracket. I have used third bracket as well as first bracket. So I haven't changed anything, isn't it? See, simply bracket x plus y plus z. Nothing has changed from here to here. See, you can write the same term in this way as well, isn't it? Nothing has changed. Similarly, the same term you can write it in this way as well. Nothing has changed. Now, what is the motive of doing this is because, see, now we can use the identity. See, a plus b. If you assume two terms as one of the term, if you assume this binomial as one term, see, a plus b, a minus b. So a plus b into a minus b, the expansion a square minus b square. So therefore a square minus b square. Now here comes the first identity. See, a plus b whole square. Now what was the expansion? A plus b whole square. A square plus b square plus 2ab, isn't it? That is why, see, x plus y whole square. In place of x, a we have x, in place of b we have y. So x square y square plus 2xy minus z square. I have expanded all the term and finally got my answer. What do I have here? Three terms, four terms, unlike terms. So this is our answer, isn't it? We cannot proceed further. Okay. Okay. For the next one also, again the same thing. See, what do I see here is L plus M plus N, L minus M plus N. Now, what do I did here? What I have done here is I have simply arranged the terms. See, this M had a plus sign, this M had a minus sign in here. We cannot use M. You cannot just directly use L minus N within the bracket, because what happens is if you use the bracket, then the sign of N must change, isn't it? But the sign of N is plus in both the terms. So what you can do is simply change the sign, place of the N. So see, L plus N plus M. Nothing has changed from here to here. It's just that it has switched its place, isn't it? In case of addition as well, switching places doesn't differ in the result, isn't it? So that is why, see, L plus N plus M, L plus N minus M. Now again the same thing. See, a plus b, a minus b, a square minus b square. We know a plus b whole square, the expansion a plus b whole square. So that is what I have done here. Minus m square, see, finally four terms, four unlike terms. So we are done here. Okay, so see, why the identities are important is because the identities allows you to solve faster. That's the only reason why we use identities in the while doing solving our sums, so that we may save time. Okay, or even though if you just directly multiply this trinomial and trinomial, you will get the same result, but it will be a bit lengthy, okay, and time consuming. Yeah. Okay, now for question number 3.1, what do I have here is I got x plus y into x minus y into x squared plus y squared. So the first two terms I can directly see as a plus b into a minus b whole square, a plus b into a minus b, the identity. So I can use a square minus b square. That's what I have done here. I have kept the third term as it is. See, and as soon as I finished up with the first two terms, what do I got? I got x square minus y square. See, x square plus y square. Again, a square, a plus b, a minus b into a plus b. See, so again what will be the expansion? The expansion will be a square minus b square, isn't it? Multiplication of binomials, terms same, just signs opposite, a square minus b square. So that is what I have done here. I finally got my answer, x to the power 4 minus y to the power 4. Okay. Now yes, what you can do is you can use the identities in some particular type of while multiplying particular constant terms as well. Like for in this one example, say 102 into 98. 102 into 98. See how you can use the identity in here is 102, it can be written as 100 plus 2, isn't it? Similarly 98 can be written as 100 minus 2. Why have we used the number 100 is because it's easier for me to square 100, isn't it? The multiples of 10 will be easier to square. Okay, or you can place any other numbers as well. Okay, instead if you use another numbers as well, even though you will get the same result, but it will be a bit lengthy. if you use multiples of 10, it will be easier for you, okay, to square the terms as well. So 102 is 100 plus 2, 98 is 100 minus 2, so 100 a plus b, a minus b, so a square is 100 square minus 2 square, 100 square. How we square the multiples of 10? All we need to do is just double the number of zeros. So we have 2 zeros in here. After squaring, 4 zeros will come. So 4 zeros, say simple. 1 with 4 zeros minus 2 square is 4. Now 10,000 minus 4 is 9,996. So we are done here. See? Okay. Now I have one question I have done for decimal in the decimal form as well. That is 1.97 into 2.03. Okay. Now this one, if you subtract 2 with 0.03, you will get 1.97, and if you add 2 with 0.03, you will get 2.03. See, every number given in your question will have some relation between themselves, okay, each other. So that is how you need to see the question, okay, approach the question. In that way it will be easier for you to handle the numbers as well. So see, a minus b, a plus b, the first terms and the second terms are same. So we know the expansion a square minus b square. So that is why 2 square is 4 minus 0.03 square, simple, 0.0009. So now when you subtract it, you will get 3.999 and 1. Okay, I hope you kids have understood. If the decimal terms are a bit complicated for you, then please practice few more sums. Okay, it will be easier for you after you practice the sums. Okay. Now for here what we have is question number 6. I've got 1003 squared minus 997. So see, as I've already said, and this one was directly given a square minus b square form. So we know the expansion a plus b into a minus b, isn't it? So that is what I have done here. 1003 plus 997, 1003 minus 997. When you add these two, you will get 2000. And when you subtract these two, you will get 6. See, 2006 is 12,000. We are done here. Okay, every number given in the question will have some relation among themselves between two. Okay, there will be some, not just relation, there will be some exact way of doing it through which the sum will be easier. Okay, this is about this question. Yeah, about this question. It would have been easier if it would have been given 3.27. Okay, it would have been a bit easier if it would have been given 3.27. I guess there's a slight mistake in the printing, but it's okay. We'll get the result for any number given. Okay, but if, as I've said, if it was given 3.27, then it would have been easier for us. Why? Because at that time, in this place, we would have got just 10, and it's, as you know, it's easier to multiply with 10, isn't it? So 6.73 into 6.73, we can write it as 6.73 whole square minus 3.37 into 3.37, so 3.37 whole square. Again, a square minus b square, so a plus b, a minus b. So after adding these two, I got 10.1. After subtracting these two, I got 3.36. See, now multiplying these two, you will get 33.936. Okay, just as I've already said, no matter what the number is given, you will get your answer. But as I've already said, if it was given 3.27, it would have been easier. Okay, I guess there's a slight printing error. Okay, now the final sum for today. Okay, 3.59 into 3.59 minus 2.41 into 2.41 divided by 3.59 plus 2.41. Okay, now what can I write in the numerator? For this to 3.59, we can square the term. 3.59 square minus 2.41 square. So it became a square minus b square. So expansion, we know a plus b into a minus b. So a plus b into a minus b. That's what I have done here. 3.59 a plus b, a minus b, isn't it? Now these two terms, see the entire term from the numerator and denominator, you can cancel it directly, see. Now the remaining sum of this question, particular question, is similar to this one. So I wanted to solve it as well. Okay. So what's left? 3.59 minus 2.41, 3.59 minus 2.41. So see, after subtracting the term, what do I got? I got my result as 1.18. Okay. I hope you kids have understood today's lesson. What I want you to do is, please practice the remaining sums from the exercise. as they are also very important for you. Okay, and if you have any problems regarding the video or regarding the sums, or if you haven't understood anything, then please do let me know. Okay, and the remaining questions, yeah, I want you to practice the remaining sums. Okay, please practice, those are very important for you. Okay, so till then, stay safe, have a good day ahead.